Module 3 review. So I was leafing through the module, hitting all the main topics. Also looked at the quiz I wrote you guys a few days ago. And if you know this, then you'll be good to go. So we'll cover all these. So this is all about parabolas. This whole module is about parabolas. Now, what are equations you can use to model parabolas? Well, this is called standard form. Takes the form ax squared plus bx plus c. Or so f of x equals or y equals. Right? Vertex form, where you can quickly identify the vertex. So it looks like this. And then there's this factored form. Now, these three functions right here are actually all the same function, and I went ahead and graphed it ahead of time. It looks like this, and I'll show you guys how to take each one of these and make it look like this. Okay, we'll say, how do you find the vertex? How do you graph parabolas? Here, I'll do that with you guys here. Complex numbers showed up, like imaginary square root of -1. You guys saw that. I'll show you guys the process completing the square, which actually help you translate from here to here, so we'll do that. This quadratic formula, I will give this to you guys. This is printed on your quiz, and also this poster staying in my room anyway. Okay, so you will have this. I just want you guys to know how to apply this. Parabola in standard form. How do you solve for like these zero solutions right here? And it's been pre-solved. You just have to know how to plug it in. Yeah, so that's all right. Right. Oh, this discriminant right here is part of the quadratic formula, so that can tell you some properties right here. Right. And oh, inequality. So what if something's greater than or less than? What does that look like? All right, so we'll do all those. Let's start with how do you take this standard form and make this graph, right? And I'll go through these one by one, right? And then yeah, so we'll start from there. All right, so how do you do it? Well, you could always make an XY table, right? So I could go here. Let's take. I'll say y equals kind of so it's f of x, but same idea. X squared minus 4x minus 45. Okay? And I say, well, I can always do this for like any graph. If I have no idea what the graph looks like, I could just start picking x values and plug them in and see what the corresponding y value is. Right? So I'm gonna try that. Now there's a cool calculator trick I think I'm gonna show you guys, is that you can hit second answer and have that stand in the place of x. Watch this trick. So squared minus 4 times the answer minus 45. Okay. So I effectively plug this into this scientific calculator. Now I hit enter, I get some junk answer that doesn't mean anything. But what if I want to know what's happening when x is 0? What's happening when x is 0? So I plug in 0 right here. I just hit 0, enter. Now the calculator's thinking, okay, I'm thinking about the number 0. Then scroll up twice, boink, boink. Right? And it'll plug 0 into your expression. It'll tell you exactly what it is. -45. When x is 0, y is -45. And maybe you saw that from the beginning anyway. 0, 0, -45. Yeah. Right, so no surprise. Right? You can immediately see the y-intercept from the standard form. Okay? And on the graph, I did go ahead and put that right here. Point. Here's the point 0, -45. Okay? Now, I could sit here and guess and check and play around with numbers all day, but you know what's really nice to know, maybe, is like, sir, where's the vertex? Now, you can see it on the visual, of course, but how would you know that like, from this? So that's a good trick because maybe it can sort of center the parabola around the vertex. I mean, that's one point, but where's it sort of centered? So x for the vertex is always at the location -b over 2a. And in this context, right here, I got a, b, and c is like 1, it's going to apply 1 here, -4, -45. So x vertex is at, let's see, that's -4, which of course becomes +4, over 2a. Well, a is like 1. Okay? So that would be what, +4 over 2 or just 2. Okay? So yeah, so this whole parabola centers around the x value of 2. So maybe they just go 0, 1, 2, 3, 4. Right? I mean, that's usually, like if you get those 5 points down, then the parabola is going to emerge anyway. Okay? So watch this. I can go one by one. I can type in the number 1. Boink. All right, so now the type is, okay, 1, something with 1. Scroll up twice. It's going to plug it into this expression, -40. Let's see that answer squared. Yeah, we're good. -48. Okay. Okay, if I plug in 2, scroll up. -49. If I plug in 3, scroll up. -48. Ooh, looks like it's bending back the other way. And 4. Right, scroll up. Right. -45. Right. So that gives me these 5 points. I could, well, I have 2 of them plotted already, but 1 comma -48. It's right there. Okay. 3, -48 right there, and 4, comma -45 right there. So start to create a parabola there. Now, what about the rest of this? See, you can plug in as many numbers as you want. Here, let me show you guys -5 and +9. So if I plug in -5, scroll, it gives me 0. If I plug in 9, scroll, scroll, also gives me 0. Okay. Now, okay. Okay, so that gives me just those points. I just want to show you guys on the table. Those are, in fact, also points. Okay? You can create as many points as you want, and the parabola naturally emerges. So you can always use this table trick, like this XY table. And so I did that for standard form. Okay? So find the vertex, okay, and then branch out from there. Okay? Now, um, what about here? If you had this in vertex form or you had this in factor form, again, all these three are the same. Okay? So let me show you guys how you would also get this exact same graph for each of these, and then I'll show you guys how to translate back and forth between. Um, there. So if you're given this vertex form, the advantage of this form is that the vertex stands out right away. Right? So if you plug in 2 for x, you see this bit will zero out, and it will leave you with negative 49, right? And that will always be the location of the vertex, right? Which I also found with the negative b over 2a method. So here, well, it would be at 2, and I plug in 2 to this, I get negative 49. But this one, it just stands out right away. So 2, negative 49. So boink, that point right there, 2, negative 49. Got it. Right? And then, well, if it's a standard parabola, then you can always go like over 1, up 1. So it's like over 1 this way, and up 1 brings you negative 48, which is what I got right here. Boink. Okay. And then go over 1, up 3. So over 1 for negative 48, up 3 is negative 45. Point. Okay. Just like these have been all along, because that's that point right there. Okay. Or you can always just pull out a table and just start plugging points in. Okay. Like you could plug this expression in my calculator and plug it in, give me the same set of numbers. Sorry, okay. And finally, factored form. What if you're given factored form? So what if you just have this? How would you know how to create a parabola? Okay. Well, the advantage of factored form is you can very quickly get the x-intercepts. You get these zeros. Because I see where x is negative 5, this bit would zero out. Therefore, 0 times anything is 0. So at negative 5 has to be 0. Boink. That's that point there. And if I plug in 9, it's the same story on this side. This would zero out, and the whole thing zeroes out. So if you plug in 9 here, you also get 0. Boink. That's that point right there. Okay. Which I also put on the table. That's those right there. Okay. So at least you have these 2 points. Now, guys, wherever the x-intercepts are, well, parabolas are always symmetrical around some central axis, like right here. So if you find the averages, then that's the location, that's the x location of the vertex. So I can say, what's the average of negative 5 and positive 9? So negative 5 and 9, right, add those together, divide by 2, that gives me the average, right? Okay. It says 2, as in the x value would be 2. Okay, so I know that the vertex is where x is 2. Right, so then I go to pull the table, I plug 2 into, say, this expression. 2 plus 5, that's 7. 2 minus 9 is negative 7. Guys, what is positive 7 times negative 7? Hey, it's negative 49, which we got before. Right? So you guys are seeing, of course, the same numbers pop up over and over again, like the same vertex, the same coordinates, because again, these are 3 different perspectives on the exact same parabola. Right? So what do you think? Right. So let's go to check this list here. So what have I done with you guys? We've been talking about parabolas, of course. Here's standard form, check. Here's vertex form, check. Here's factored form, check. Okay. Actually, here, I'll tell you guys a little bit more about factored form. Okay. Because how do you go from, actually, I'll talk about that in a minute. Okay, let's go to this checklist. Okay. I'll show you guys how to find a vertex. You can either do negative b over 2a from standard form, or you can find the average of the x-intercepts here. Right? So put that check and plug that x value into the equation, find y value. Okay. And of course, vertex form, it gives it to you almost directly to negative 49. Okay, so there's the way you can find a vertex on any one of those. Okay, I showed you guys how to create a table and graph this multiple ways. Check. Um, okay, yeah, okay. I think it's a good point here to show you guys how to go back and forth among any of these. Right? So what if you're given one of these and you want a different form? Right? Maybe I have standard form and I really would like to have vertex form or factored form. So let's start with turning standard form. Let's go from standard form to factored form. Standard to factored form. Okay. So here, I'll take this example. And so if you have y equals f of x, y, same idea, x squared minus 4x minus 45, right? If I suspect that might be able to be factored, then what I could do is like start out like this. Okay? Maybe I have x and x. Okay? Now, in the back of my mind, I'm thinking FOIL, F-O-I-L. Now, I'm not foiling forwards at times, but whatever this answer is, I could foil it first, outside, inside, last, and it should bring me back to the standard form, right, so I can check my answer. Okay. So what are two numbers that add to -4 and multiply to -45? Well, see 45. I know 9 times 5, so that might be my first guess. Maybe something to do with like 9 and 5. Okay. In fact, if this b term is overall negative, that means that the negative 9 is going to be, well, the negative goes on the big number and the positive goes on the small number. Now, is that right or not? Well, I can check by foiling. So let's do first, x times x is x squared. Outside is plus 5x. Inside is minus 9x. And last is -45. Okay. These two terms can combine because they're both x terms. It gives me x squared minus 4x minus 45, which is exactly what I started with. Ding. So that's work. So this is standard form, check. And this is factored form, right, which gave you guys ahead of time. So that's just how to turn that into that. Right? You can also go backwards. Oh, but that's what I did right here anyway. If you have factored form and you want standard form, you just FOIL it out, or just like I did here. Point. Okay, so now you can go back and forth between these two. Okay, so that's nice. Okay. Right, how about how do you go back and forth between, let's go standard form to vertex form. Let's do that. Right, let's go standard to vertex. Okay? And actually, standard to vertex is going to involve this process here called completing the square. So this will also check off this box. Right, help you out. Right, so let's take the same example. Let's go y equals x squared minus 4x minus 45. Okay, so it's my example. I've been using it over and over. Now, what I'm going to do here is focus on these x terms, and I want to factor this so that it forms a square, and it's completing the square. Okay, so I need something like this, like x minus something squared. Okay. Now it's -45, I'm going to be way out of the way here. Now it's still part of the expression. I've just leaving some space. Okay. If this was plus, this would be plus, minus, minus. Okay. Now I'm still thinking FOIL in the back of my mind, FOIL. But you guys know what something squared is. It's just that thing times itself. Okay. So it's like x minus something. Same idea, right? So what is the something that goes here so that when it adds to itself, it creates like -4. Right? Well, it's got to be okay, -2 and -2. Wouldn't it have to be that? Right? So I'm thinking it's back in my mind, or maybe jot this out on paper just like I'm doing here. Thinking, okay, first x times x is x squared. Bing, that's that one. Okay. Then x minus 2, sorry, -2x, I should say, and -2x. -2x, -2x, that's my outside inside. Brings me to -4x. Bing. So we're on good footing so far. I'll go ahead and confirm this is in fact 2 right here. So x minus 2 quantity squared is right here. But there's an interesting consequence, and I'll do this in pinking to make this last point down. It's this last term. Guess what's -2 times -2? Isn't that +4? Ooh. So if I FOIL this out, I actually have a +4 here that didn't show up in the beginning. But okay, I mean, aside from this -45, that's separate. Okay? So to restore balance, I have to subtract it because otherwise it's excess. Right? Because this right here, let me FOIL this out. This is x squared minus 2x minus 2x, so minus 4x. Right? But I have this +4 tagged on the end. Right? I mean, this and this look like this and this, but this extra 4 is too much. So I have to subtract it out. And that restores balance. So that this is equal to this. Okay. So I'll put all this FOIL in a dot cloud. Right. So maybe we have to write that margin on paper or this one. Right. Right. And then continue on here because there's one more step. Right. All I have to do is combine the two constants, the -4 and the -45. Then it gives me y equals x minus 2, quantity squared, minus 49. Oh yeah. Oh yeah. Look at that right there. -4 minus 45 gives me -49, which is exactly what my vertex form looks like. And of course, it immediately tells you the vertex, and we've gone through this multiple ways, right? How it looks like that. Yeah. Yeah. What do I do here? Right. And of course, if you want to go backwards from vertex back to standard, all you have to do is FOIL this out and then bring constant here. I'll do that with you guys too. Let's do this whole process backwards. Let's go not from here to here, but here back to here. So I can go y equals, FOIL this out. So x squared, actually I did that right here. X squared minus 4x. I will get a +4. Right? I still have this minus 49. And if I bring these two together now, as the constants, I get y equals x squared minus 4x minus 45. Hey, that's where I started to begin with. That's what I gave you in standard form to begin with. It's the same thing. Check, check, check. Oh yeah. Oh yeah. Right. Right. So, um, right. So should you guys have to go from standard to factor and back and standard to vertex and back? Right. Right. So you can navigate your way back and forth among all of these. Right. And in doing so, here, remember, what I just showed you here, and I'll spell this out. This is called completing the square. Okay? Right, completing the square. Right? So the rule for completing the square is whatever this b value is right here, in case -4, okay? If you take half of that, that always shows up here. But then if you square it, because you'll inevitably end up doing that in this last term of FOIL, well, you do have to subtract that off, right, to restore balance. Right? Okay. Okay. So it's half of this b term always goes here, and then you square it and subtract it off, and that restores balance. Okay? If you're not sure if you did it right, then you can always do this FOIL and check your work, just like I did right here. And how many lines is this? One, two, three. That's not bad, right? And then you got 4, 5, and 6 to check my work the other way. Yeah, right. That's that. That's not too bad. That's all right. Okay. Okay, so show you guys in completing the square. Um, Here, I'll go ahead and hit complex numbers and this imaginary number. Okay, something like that. Actually, yeah, let's do that. So now this one I have to bring up a completely different example because this usually involves parabolas that, like if it is a parabola that doesn't touch the x-axis at all. Okay? So I can come up with something. Let's go y equals x squared plus 9. Now I know if I had, it's completely different, y equals x squared minus 9. I know a different way I could factor that would be like x plus 3, x minus 3, right? Because then FOIL x squared minus 3x plus 3x cancels, and then 3 times negative 3 is -9. Yeah, so that is that. Check. The same thing. Okay. But if it's like x squared plus 9, well, right, not so much. Right? It doesn't factor with real numbers like this. There's no way to do it with real numbers. Right? But what you can do is say x plus 3i and then x minus 3i, where remember I represents the square root of -1. Right? Remember that? Okay. So watch this. If I FOIL this, first, outside, inside, last. Is my FOIL. First, outside, inside, last. Okay, okay, get x and x is x squared. Okay, so that looks like that. Ding. Okay. The outside and inside do cancel out because 3ix and minus 3ix, those cancel. Right? So it's complex conjugate. Think that way. And then this is minus 3 times 3 is 9, and then I squared. But guys, if I is root -1, isn't I squared equal to -1? Because I just squared both sides. Right? So, hey, and that's this right here. It's the same thing. So this is really x squared minus 9 times -1. The negatives cancel. It gives me x squared plus 9, which is exactly what I started with. So it's the same thing. Okay. So this could be standard form, and this is factored form that involves this imaginary number, right, which is the square root of -1. Remember, your calculator cannot do that. Square root of -1, it just says domain error. Right? But if you get deep into electrical engineering, and your book had a few puzzles related to this, then actually this I ends up being really useful in the real world. Yeah, sure thing. With like alternating current, sure does. Yeah. Oh, here's something else with I. Okay. Is if I is equal to the square root of -1, and I show you guys, okay, therefore I squared is the square, which is -1. Okay. I wonder, what if I keep going? What if I keep increasing powers here? So I to the third, well, that would be I times I squared, which is, well, I squared is -1, and I is I, so this would be -I. Okay. And then I to the fourth, isn't that like I squared times I squared? Which is like -1 times -1, which is +1. Okay? So let's look at the results here. Here, I got, there's I squared, I to the third, I to the fourth. Yes, I to the fourth is 1. Well, if I do I to the power of anything after that, like I to the fifth, isn't that just I to the fourth times I? Okay? And I to the fourth is 1. That's that. So this is just 1 times I. That's just I, which is the same thing as I. I is I. Right? So what I'm trying to show you guys is that this is a 4-part pattern right here. Okay? And once you have any power on I that's greater than 4, then It's just like follows multiples of 4. So like some of you guys had a textbook question, something like what's I to the power of 29? You say, well, that's the same thing as I to the power of 28 times I to the 1, because powers can add, exponents add together like that, right? And I did 28. Well, 28 is a perfect multiple of 4. So this part right here is just equal to 1, because I to the 4, you just do that 7 times over. It's just 1 times 1 times 1 times 1 times 1 times 1 times 1, which is 1. And then I have an I left over. So I to the 29 is I. It's the same thing. It's the same thing. I to the 29 is I. Right. You do that? All right, so we did say complex numbers, check. I check. Okay. Uh, Last thing I should say about complex numbers is we're talking about complex conjugate, like x plus 3i and x minus 3a can be complex conjugates. If this showed up in the denominator, you can multiply both sides, top and bottom. But here, I'll do it real fast, although this is not going to show up on the quiz. But if you had something like 1 over um, 3 plus 5i, and you wanted to simplify this so that I is not in the denominator, you can multiply both sides by 3 minus 5i, or top and bottom, I should say, 3 minus 5i. Now, the theory of why this works is that top and bottom are the same, so you're technically multiplying by 1. You're not actually changing it. But also, when you FOIL out the denominator, the i's disappear. Whoops, first, outside, inside, last. So it's the same thing as, yeah, well, the numerator, now you're stuck with the 3 minus 5i. But denominator, you got what, 9. Now the outside and inside cancel because it's the complex conjugate. It was set up to do that. So 59 minus 59 zeros out. Then you got minus 25 I squared. Remember, I squared is -1. So it's the same thing as, okay, here's my numerator. This is 9 plus 25. And then you can actually add those together. What would that be? 34, I think. So this is 3 minus 5i over 34. Okay. Okay, so like that. Okay, so that's how you find a complex conjugate. All right. Uh, let's get to quadratic formula, which is this right here. Right. So if you have a standard form, like parabola standard form, like a t squared plus b t plus c, or you can say a x squared plus bx plus c. Right? And I put t here because see a common puzzle example of this is what's the height of the ball as a function of time? If you throw a ball straight up, go up and come back down. Actually follows the parabola shape, height versus time. Okay? So this is useful in physics. If you want to take my physics class, you get to see physics examples of this. Okay? Your math textbook was using the same type of examples. Okay? But now, if that's equal to 0, okay, well now you can solve for something because it's not this whole parabola anymore. It's just the part where it's equal to 0, which usually you have two solutions. Although if just the vertex touches one place, there'd be one solution. And if the parabola doesn't touch at all, then there would be no real solutions, but there would be complex solutions. So let's apply this to my main example from the beginning. This one right here. Okay, so what if I have this form right here? So let's go y equals uh, x squared minus 4x minus 45. Okay? Now let's go ahead and set that equal to 0. Right? So I'm getting rid of the y equals, and I'm just saying it equals 0, right? Equals 0. Okay? Which means that like when I had y equals, it was this whole p parabola. When I get rid of that and I just say equals 0, now I'm just honing in on these 2 points where y is equal to 0. Yeah. Okay. Well, this has been pre-solved. It's just x equals it's right here. Right? It's this one right here. Right? So if I can get it there. So my A is 1, my B is -4, my C is -45. So it goes negative B, which is like -4, which is going to become positive. Now, okay, plus or minus, that tell me I can potentially get two solutions out of this. Square root of B squared minus 4, A is 1, C is -45. Right? It's all in my radical. All divided by 2a, 2 times 1. Okay. Here, since I get pretty close to the edge of the paper, let me write that so it's looks a little cleaner. We got -4 plus or minus square root of, okay. Guys, this b squared, isn't this always going to become positive regardless? Okay. So whether b is positive or negative makes no difference for this b squared part. Okay. This is always going to be like this. Okay, so I'm going to do that. Okay. And then -4, 1, -45. Okay. Now, in your calculator, make sure to group everything under the radical in parentheses and also group together the numerator in parentheses. That's why I wanted to rewrite that so I could fit in these extra parentheses here. Something like that. Okay. These negatives cancel. Looks like that. Okay. So now we're on our way to solving this. here, I can solve this out by hand. Now, if you need to plug this in a calculator, you can totally do that. Right? So you guys have had lots of practice for the past few weeks plugging these in the calculator. Um, here, how about that? I'll go ahead. Here, I'll throw in one more step. So 4 plus or minus square root. All right. Now, these negatives also cancel. And what's 16 plus 4 times 45? That's 196. Right, and this is all divided by 2. Right, make sure parentheses, parentheses, and so on. Okay, now 196. Right, 196 does have a perfect root, which is 14. 14 squared is 196. Okay, you could continue this way, but let's say at some point you want to plug this into the calculator. Right, so I'll do this at this point. So I always do this. Start, open a parenthesis. So you open the numerator, then you have your negative b, case positive 4. Now plus or minus, go ahead and pick one, and we'll do the other one later. So I'll pick plus. Okay. I'll do square root of 196, or what you might get the whole expression. You can type this whole thing in here if you want. Okay. Now, this calculator opened a parenthesis for me as soon as I open the root. As soon as I close a parenthesis, it stops square rooting. So you have to know that. And then I close another parenthesis, it closes the numerator. So now I have all this grouped together. And then divide by or 2. You might want to put some parentheses possibly if you have a bunch of stuff down here. Okay. So I'm getting 9. Let me say or. Now scroll up, scroll over. Remember this was a plus or minus. Just put in a minus, point, and then gives me -5. Right? Right. And since those are zeros or solutions, that corresponds to the coordinates 9, 0, and -5, 0. Well, I should say or. Right? Uh, -5, 0. Right? Does that match my graph? 9, 0, and -5, 0? Let's see if it does. There's 9, 0, boink. There's -5, 0, boink. Yeah, which we made a whole table earlier, and we're mapping all those out. Right, so this is like multiple perspectives on the same idea over and over. And quadratic formula. Right? All right, so apply quadratic formula. Right. Now, some couple of things to point out about quadratic form, like some properties. Look at this right here. See this negative b over 2a? We did that way earlier in this review to get the vertex. That's the x location of the vertex right there, negative b over 2a. Right? And another part of the formula that's interesting is this discriminant. Everything underneath the square root, b squared minus 4ac. Now, you guys know from um, like imaginary numbers, you're not allowed to take the square roots of negatives. What that means is this. If um, b squared minus 4ac is greater than 0, then uh, okay, I'm organizing this. Okay. So if this is positive, then you have two. Whoops. You have two real solutions, just like I just showed you guys. That's exactly the last thing I did. Okay. So this came out positive. This b squared minus 4c. It was positive 196. Okay. Hence, I have two real solutions. Okay. These two real solutions right here. Okay. Okay. If b squared minus 4ac is equal to 0, well, then what you would be doing is doing plus or minus a 0 right here, right? Then you only have one real solution. And what that would look like on a graph is it would look like um, it would look like the parabola just touches the x-axis, just touches the x-axis. Okay, and so it only touches one place, one real solution. Okay, if b squared minus 4ac is negative, like less than 0, then you have no real solutions, or maybe I should say like 0 real solutions. But you could have complex solutions that involve I. Remember, I is the square root of -1, so things like that. Okay. Actually, let me take through my notes from earlier. Okay. You guys remember this one right here? Like this? So this one would have complex solutions at -3i and positive 3i. Okay. Here, let me feed this through the quadratic equation or make a quadratic equation with it. And I'll show you guys that you get exactly those solutions that we got from factored form anyway. So And if I have y equals, so that's 1x squared. Now there's 0x's, so I'll go ahead and write that explicitly. 0x's, and I got a plus negative. This and this one, the same thing. Okay? I'll show you guys through quadratic equation. I'll get the exact same zeros I would have gotten by factoring it. So x equals negative b, which is like 0 anyway, right? Plus or minus the square root of b squared minus 4ac all divided by 2a. 2 times 1 or 2 if you like. Right? Okay, so let's clean this up. 0 goes away, whatever. Okay, get a plus or minus square root. Now this comes out to negative 36. Okay, and this is all divided by 2. Well, I know what the square root of 36 is. That's just 6. But what about this negative? Hey, that's what I is for. I is the square root of negative 1. Yay. So that's x equals, okay, so I still have the plus or minus. Root 36 is 6. And then the root of negative 1 is I. This whole thing is divided by 2. Right? So plus or minus gives me two answers. 6 over 2 is like 3. So x could be negative 3i or positive 3i. Yeah, which is what you would have gotten out of factored form anyway, because there's factored form. And if you set that equal to 0, you would reach the same conclusion. Yeah, it's the same thing. Just like that. Like that. All right, so yeah, discriminant check. Okay. Um, you know what? Here, let me fit in one more idea before I get to quadratic inequalities. Okay? Is that let's look at an upside down parabola like this one. Okay? So if you're ever asked a question, like a word question, like what's the maximum height of all, right, then wouldn't that be represented by the vertex of the parabola? So I showed you guys how to find vertex earlier, but multiple ways. You could negative b over 2a. You could factor it and find the average. You could do vertex form. Okay? However you do it. There's multiple ways to find vertex that could represent the maximum height of all. Another common example that was used in your book is revenue as a function of price. There's so many questions you guys saw was like, there's a company that they start increasing the price on some product. And at first it starts increasing the revenue, but at some point the product gets too expensive, so less people are buying it and the revenue goes down. So it creates this upside down parabola. If you want to maximize your revenue, that's like also finding the vertex, wouldn't it be? Okay, so that's some of the examples. All right, so last topic here, let's look at quadratic inequalities. Right? So basically, if I just take this and I say, instead of equals, what if I just made that greater than or less than? So let's say, uh, what if I have y, let's say strictly greater than, and then something like this, x squared minus 4x minus 45. Or I could have written that, or I could have written that, because these are all identical scenarios. Okay? So however you want to write it. Okay? Now, you know what the main graph looks like? It looks like this. Okay? So here, I'm going to split this paper and do a couple examples here. Let's do one that's strictly greater than. Let's do another one that's less than or equal to. And let's use the same formula. Here, I'll write a little different. Let's do vertex form this one. X minus 2 squared minus 49. Okay. So first thing is, of course, you guys do see these are the same parabola because I've been showing you guys that over and over. You know what that parabola looks like? And so I'll sketch a rough looking function of it, or the set of axes here. So I've got y, a couple of y-axes, got a couple of x-axes. Go ahead and label those y versus x, and y versus x. Okay. Right, so just to dash off this parabola real fast, it'll have x-intercepts at negative 5 and 9. Let's say negative 5 is here, boink. Let's put 9 right here, boink. I mean, this is approximately a scale. It's pretty close, right? Boink, boink, quite close. Okay. And here's the vertex at 2, negative 49. So let's go to 2, negative 49, boink. And then 2, negative 49, boink. Something like that. Okay. Okay, so I got some key points on what's going to become parabolas. Okay, now, guys, if I say strictly greater than, I have to do something funny for parabola. I have to dash it, dash, 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 because you're not actually allowed to include any points on the parabola because it's not allowed to be equal to. It has to be strictly greater than. Okay, right then, guys, greater than, is that above or below? I think that would be above, right? So it's got to be this region right here. Okay, let's say you either weren't 100% sure on that, or okay. Could you pick a test point? Right? Like, how about this point, 0, 0? And I'm making a claim that that is part of the solution set, 0, 0. So let's try that. Is that part of the solution set? If I plug in 0 for x and 0 for y, does it make a true statement? Is this point right here, 0, 0, part of the solution set? So if you say is 0 greater than 0 squared minus 4 times 0 minus 45. Well, let's that not go away. So basically, is 0 greater than negative 45? Yes, it is. The fact that that is a true statement, being true, means that 0, 0 is part of my solution set. So I did, in fact, shade the correct region for the graph. How about um, uh, less than or equal to? Now, if this is less than or equal to, I can make a solid parabola. Right, so I'm making the same parabola, except before I dashed it, now I'm making it solid. So go like that. It's the same parabola we've been using all along since the beginning of this video. But this one, less than, well, I think less than or equal to would be everything under the parabola, which would be the opposite region. So I'm going to shade the opposite region. Should look like that. Right? Now, I could take a test point anywhere here, like 0, negative 100, and that would be a true statement. I'm going to take the same point 0, 0. So 0, 0. And I'll show you guys that this is falsified, that this point does not work. Okay? So is 0 less than or equal to? So 0 from this y value 0. Okay? And then 0 for x. 0 minus 2, quantity squared minus 49. Okay? Well, this is positive 4. The positive 4 minus 49 is definitely negative. Let's say negative 45. So is 0 less than or equal to negative 45? Definitely not. Yeah, 0 is not less than a negative number. So, so false, which means that you would not want to shade the side of the problem that includes the 0, 0, which of course I did. So we got that. So there you go. Quadratic inequalities. Check. Yeah, so I think that's about it. So it's pretty all encompassing right there. Yeah, anything that I would ask you on a quiz would be yeah, something that we covered right there.